Good morning, boys and girls, and welcome back. Mr. Mortar here to teach you about graphing exponential growth functions. And we're going to talk about exponential functions in this unit in general. All right, so let's start off with a little definition. Exponential functions are a function where you have a constant or some base risen to a power of x. So far, everything we've talked about has been like, x has been the base and we've had different powers, a squared power, a 1/2 power like in the last unit, or a 1/3 power. All right, but now we're going to switch things around, and the base is going to be a constant and the exponent is going to be a power. Something like y equals 2 to the x or 3 to the x, something like that. Okay, where x is now in the exponent. All right, so that's an exponential function when the x is in the exponent. And then an exponential growth function is something that's going to grow or get bigger. It increases in proportion to its current value, such as it's always going to double or it's going to triple. All right, and we know we have an exponential growth function when the b is greater than 1. Okay, if your base, in this case my base is 2, if that base is bigger than 1, that is an exponential growth function, and that b, the b value, we call our growth factor. Okay, and then again, we're going to talk about these graphs will have an asymptote, but they're going to have a horizontal asymptote. And again, that's just a line that the graph will approach and get close and close to. In this case, they won't ever cross, but again, it can cross horizontal asymptotes sometimes, as we learned with rational functions. All right, so let's, again, like all functions, we start to with our parent function. So let's start with a parent function for an exponential growth, and let's see what it looks like. All right, so for this case here, again, we're doing y equals b to the x, where b is the base, bigger than 1, so it's a growth, and there's, again, all sorts of different graphs we can use, okay? In this case, we're going to use a base of 3, so we're going to talk about y equals 3 to the x, all right? And so now let's try to plug in some x values and see what happens. Whenever we graph a parent function, we tend to like to use these values in the middle, -2, -1, 0, 1, and 2. And some of these are maybe a little bit more hard to evaluate than others, so I'm going to start with the easy ones, and I'm going to start with x equals 1. All right, so we're in equation y equals 3 to the x. If I plug a 1 in here for the x, now I get y equals 3 to the first, and now you can see why that's a nice easy one, and we end up with 3. If I stop and I plug in 2, when I plug in 2, now I get 3 to the second, or 3 squared, which is 9. And then you can say, if I'm going to plug in 3, I'm not going to do it because you can see this is going to get real big real fast. 3 to the third would be 27. And so this gets huge quickly, will quickly grow off of our graph, and that's why it's called an exponential growth function. All right, let's go back just a little bit. What if we were to plug in 0 now instead of 3 or 2 or 1? And if I plug in 0, well, anything to the 0 power is 1. Doesn't matter what you raise to the 0 power. And then now we got to plug in -1. And if you remember, when you plug in -1, that negative exponent sends it to the bottom, right? So this really becomes 1 over 3 to the first, and 1 over 3 to the first is 1/3. So the negative exponent doesn't change the sign. It doesn't make it a negative number. It just sends it to the bottom. So if I plug in -2, that negative exponent would send it to the bottom, and I'd end up with 1 over 3 squared, or 1/9. And then if I had to go back one more, I'd have 1 over 27, right? All right, so now let's plot these points on our graph. All right, we're going to talk about some patterns here in a second to help us graph these. But again, the one we're going to start with here is 0, 1. All graphs, most graphs are going to pass at the point 0, 1. So I can start at that point. And then I have the point, I got to go over 1 and up 1, 2, 3. And then I got to go over 2, 1, 2, and up 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, like I was saying, this is going to grow off your graph relatively quickly. See how fast that's up and off? Now, if I go the other direction, -1, I'm only going to go up 1/3. And if I go to -2, I'm at -1, or I'm at 1/9. And then I said if I did, it's the third, it'd be 1/27. These are going to get smaller and smaller and smaller. Now, as they get smaller, will they ever cross that line? No, because they can't be negative. As that number gets bigger on the bottom, they just get closer to 0. So that creates the horizontal asymptote for us, right where I put that green line. And now what you could do is you could go ahead and you could sketch your graph. Okay, what we do is we come along our asymptote, and then up, it leads into a nice smooth curve. And so this is what those functions look like, okay? Slow line and then growing faster and faster and faster. Okay, so let's see if we can pull out some commonalities of this graph here. We want to notice that the graph is growing, right? It grows or increases from left to right, and it's going to pass through the points we said always 0, 1, and 1, b. 1, whatever the base is. Okay? And I'm even going to add one more point there. Negative 1, 1 over b. Okay? These 3 points are going to help us graph ours, and they're really the ones, since they're the ones we can find the easiest, we're going to use those most often. All right? Notice that the x-axis is an asymptote of our graph. And it might be shifted up or down. I don't like what this word here. And it could be shifted up or down. We don't have this stuff yet, but with our HK values. Okay, we're going to get into the HK stuff here in a little bit. And we're going to talk about how it can be vertically stretched or vertically shrunk. But in this case, I don't think we have any of that stuff. I'm just going to cross this out for right now. I think important, just know that the x-axis is an asymptote, and that graph, we're going to be able to shift our asymptote here in a little bit when we start shifting our graphs. All right. The domain of the parent function is all real numbers because we can plug whatever we want in for x. And the range of the parent function is y is greater than 0. All right. This will approach 0, we said, as we go to the left, but it'll never actually get to 0. It won't equal 0 because in order to have a 0, you have to have a 0 on top of your fraction. And we are always going to have a 1 on top with a negative exponent. All right. And then if we wrote this in our HK form, this is what it's going to look like. Y equals a times b to the x minus h plus k. And that's what we'll start talking about the shifting here in a minute or two. All right. We'll talk about how we can shift and stretch our graph. So, with all that being said, the steps to graphing an exponential function. We say first, you want to identify your parent function. Okay. Identify the b to the x part. Okay. Find that base. Then you're going to find the 3 crucial points you need by using, this is the second step, using x is 0, 1, and negative 1. We're going to plug those in. Okay. Then we're going to shift the graph or translate the graph using our HK and A values. And then we're going to sketch our exponential growth function. Okay. So again, if you've been keeping up with our graphing so far and the HK stuff, the last one, really should find today to be a lot of fun and quite easy. All right, so let's take a look at number one here. We want to graph y equals 2 to the x. All right, and so we say first, identify the parent function, and that's what we mean. Like that is our parent function. If we had the HK stuff and the A stuff, we'd get rid of that down the road. But in this case, we just have the b to the x, and so that's our parent function. All right. And now once we identify our parent function, we're going to find our 3 critical values by plugging in 0, 1, and negative 1. We talked about when you plug in 0, you will always get 1. 2 to the 0 is 1, right? If I plug 2 to the first in, I'm going to get 2. I'm going to get my base. And if I plug in negative 1, you're always going to get 1 over your base, or 1/2. Okay, so we're going to find these 3 points. And then now we're going to shift our graph if we have to. In this case, again, we didn't have any H's or any K's, so this is going to be very straightforward. I'm going to graph the graph just like normal, no shifting needed. So we have our points at 0, 1, 1, 2, and negative 1, 1/2. And now we're going to use the idea that we know our asymptote is the x-axis, and that this is growing to sketch our graph. So I sketch in my asymptote, and now I'm going to draw the graph. I know it's going to have to be a nice, smooth curve, growing function. I like to start on the asymptote, and you can draw right on it, and then smooth and curving. And again, it's got to grow quite fast, right? We want to get up there, and it's a nice, smooth, curving graph like that. Don't have it coming off to the side too much like that. Don't have a curve back on the inside. Those are all bad things that we see sometimes. Okay? Nice, smooth curve growing, and it should end almost going straight up, or if not, going straight up. Don't just hit a line either and go straight up, though. That also looks weird. Don't just hit a line and, yeah, I'm going to go straight up. Okay? Make sure, again, it's nice, smooth, and curving. Looks like that. The domain for all of these functions will always be all real numbers. Written in interval notation like that. And the range will always be, as if you don't shift it, the range will always be y is greater than 0. Written like that. All right? And there's our first one. See, easy peasy to graph. Oh, and I almost forgot we have to do the horizontal asymptote, or write our asymptote. This is a horizontal line again, so it's going to be y equals, and again it's at y equals 0, so y equals 0 is our horizontal asymptote. Make sure again you have the y equals when you're writing these. Okay, I'm going to fly through this one a little bit faster. Step 1, identify your parent function. Done. And now find my 3 points. And so when you plug in 0, you get 1, 1, 4, -1, you get 1/4, or 1 over b. And now I need to graph these along with the asymptote. If there's no shifting, then your asymptote is always y equals 0. And then again, you're just trying to estimate where these things are at, especially the fraction ones. Like my 1/4 looks maybe like it's more like a 1/2. But you just kind of want it to be close, somewhere between 0 and 1. And now you can sketch your graph. You can see that when your b is bigger, it's just going to grow faster. But it's still going to have the same look. My domain is all real numbers, and my range, again, in this case, can be y is greater than 0. All right, let's get more interesting with this. Okay, now we've got an a value, but my first step is the same. I want to identify the parent function. And that is just the b to the x. So y equals 2 to the x is my parent function. I'm going to go find my 3 points. So that's 0, 1, 1, 2, -1, 1/2. And then now what I need to do with that a value is I'm going to multiply, that's my vertical stretch, right? So I can multiply the vertical or the y part by that 3. So I can multiply all these green numbers down here by 3. So the points become -1 3/2, 0, 3, 1, 6. And now I'm going to graph those points. Again, there's no shifting yet, so these are all going to be from the same origin here. And my asymptote is still at y equals 0. All right, so when I graph the 3 points, 0, 3, 1, 6, -1 3/2 is like 1.5. I get these points. So you can see it's the same growth we have going on. It's just stretched a little bit. So when you sketch your curve, again, just nice smoothie curve, start on the x-axis, start on that asymptote, and have it nice smoothie curve growing up. The domain in this case is still all real numbers, and the range is still y is greater than 0. All right, I want you to go and I want you to try number 4 on your own now. It's just like number 3. If you need a hint, first step, find your parent function. Then you're going to find your 3 points, 0, 1, 1, 4, -1, 1/4. Then you need to multiply those by your a value. Sketch your horizontal asymptote, it's in the same place, y equals 0, and then plot your points. In this case, you might have guessed because our a value is negative, it has been reflected over the x-axis, and now it's going to be going down instead of up. It is still a nice smoothie curve, but it's going down. This is called reflected growth. The domain is all real numbers still, but my range is y is less than 0 since it is going down. And that's it. Fairly easy. All right, number 5 here. Let's get HK involved now. So step 1 again, identify your parent function. You just want the base of the x. Ignore everything else, so y equals 2 to the x is my parent function. You're going to find your 3 points, -1, 1/2, 0, 1, 1, 2. But now when we go to graph, we're going to have to shift everything. If I've got an x minus 3, again, that's going to shift our graph to the right 3, and a k value of +1 is going to shift everything up 1. So what I like to do is actually go and redraw my origin, right 3 and up 1. Kind of like we did for our rational functions. And now I'm going to graph my 3 points off of this new set of axes, off this new origin. And now because we're going off that new origin, you can see that we have shifted our graph a little bit, so that you have to shift the asymptote. And so, again, the asymptote is going to be tied in with your k value here. So now it's at y equals 1. And now I can sketch my graph. And it would look like that. The domain is still all real numbers. Now my range is y is greater than 1 since it's been shifted up 1. Again, your range will be tied to that k value, just like in previous graphs. All right, go ahead, and now I want you to give number 6 a try on your own. You'll just check your answer here. All right, I'd say pause it for a second if you need to look at all the details here, but this is what your graph should look like. All right, let's move on to our last one. Now we've got A's, H's, and K's. So again, first identify your parent function and find your points. After you find your points, then you need to multiply them with the a value. Once you multiply the y's by 4, now you need to shift your origin right 1 and down 2. Now I'm going to plot my points off that new origin. The pink one's on the bottom. And then I'm going to sketch my nice smooth curve. It'll look like this. Domain is all real numbers. range is y is greater than -2, not or equal to, just a parenthesis, and that's what was y.